Okay, everyone. Last but not least, in Chapter 3, we're going to do 3.7. We are skipping 3.6, so don't freak out and think you're missing something here. We saved that for later in the year, and we're moving on to 3.7. Now, 3.7, we have done all of our standards, and 3.7 is going to hit hard on the FIF.6, which is your average rate of change. And that is a review, but now we're going to compare it with linear, quadratic, and exponential functions. So linear and exponential were from secondary math 1. Quadratic is what we add on in secondary math 2. And then we're really going to hit hard here on the creating, graphing, and comparing the linear, quadratic, and exponential functions. So starting off, 3.7, comparing linear, quadratic, and exponential functions, we're first going to just review our linear, quadratic, and exponential functions. So linear, graphically, straight line. It can be moved up, it can be moved down, but that's our linear graph. We've got y equals mx plus b. M, if you forgot, is your slope. B is your y-intercept. And then if we're talking about rate of change, what we need to remember for linear is that we have a constant rate of change. Moving on to quadratic. So quadratic is what you learn in secondary 2. That's what we add on. And this guy is your parabola. This guy is your y equals ax squared plus bx plus c. That's how we write his equation. And this guy is not constant rate of change. In fact, down here near his vertex, when he starts out, he goes over 1 up 1. Then he goes over 1 up like 4. Then he goes over 1 up a whole bunch more because he's squared. So whatever value you're at, if you're at 1, you square it, that's 1. So that's a slower rate of change. If you're at 5 and you square it, that's 25. That's a bigger rate of change. So his rate of change is going to change depending on where you are at on that function. Exponential, again, this is back to secondary math 1. So he kind of has his asymptote right there, his horizontal asymptote, and then he goes up like that. Exponential, y equals a times b to the x power. And then your b is your common ratio, which if you forget what that is, that's okay. We're going to go over it. And your a is your y-intercept. And for our purposes, we're going to leave it kind of simple like that. We're not going to get into anything too complicated. And then again, this guy also does not have a constant rate of change, but his rate of change starts out really, really slow near his horizontal asymptote and then gets faster, 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 faster. Now, if we had to put these guys in order from the slowest rate of change to the fastest rate of change, which one do you think would be the slowest? Which one do you think would be in the middle? And which one do you think would be the fastest? Eventually, exponential is always the fastest. Okay, he takes off at a really, really fast rate. Quadratic is somewhere in the middle. You know, he does get faster and faster, but nowhere near as fast as the exponential. And linear, he just hangs out. He's just what he is. He's the slowest. He's just always doing the same thing. Now, our first 3 examples is we're going to use a graph to identify our functions. So number 1, plot the points. Tell whether the points appear to represent a linear, quadratic, or exponential function. So I'm going to take my graph. I'm going to go 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. My first point is at 4, 4, 2, 0, 0, 0, 1, negative 1/2, negative 2, 4. So I'm taking a look at that. What graph does it appear to represent? I'm hoping you're saying quadratic, because if you connect the dots, you can kind of make like a nice U in here. You got your vertex down at the bottom, and he looks like a quadratic graph. Letter B. Gonna kind of start the same way. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. We've got 0, 2, 2, 8, 1, 4, negative 1, 1, negative 2, 1 half. What do you think? I'm thinking exponential. Kind of follows your exponential curve. Slow at the bottom, faster at the top. Letter C. Let's see. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So we've got 0, 1, 2, 4, 4, 7, negative 2, negative 2, negative 4, negative 5. What do you think? I'm going to go with linear. And just so you're aware, I didn't have it in here, but there could be an option for neither as well. So if you get something really funny where the dots are just kind of all over the place, you can pick neither. But that's how we just use a graph, plot some points, identify what it appears to be.